Hello everyone. Even though you did this as your anti-set when you started class, I thought I would go over it again just in case. We were finding the surface area of the following figure, leaving your answer in terms of pi. So here we have a cylinder with a top piece. We have a cone, which is just the lateral area of the cone, and they're being connected there. So let's getting the surface area of the cylinder first. I'm doing 2 pi RH plus just one circle on the top, pi r squared. We don't have two of them because it's connected there from the cylinder to the cone. So now when I plug everything in, the radius and the height, I get it to be 85 pi feet squared for the cylinder piece. Now taking a look at the cone, this is just finding lateral area of a cone, which is pi RL. We need to figure out what the L is right here. And the way to do that is to do your Pythagorean theorem again. So when I plug in my 5 squared plus 12 squared to get my slant height and square root it, I get it to be 13 as my slant height. Now when I plug it in my formula, our radius is 5, our slant height is 13. We multiply it out, we get 65 pi. And now I add both of these together. So the total surface area of this shape is 150 pi feet squared. If you haven't had a chance, you should take a look at your answers to the homework. This was the answer to 11.3 here, somewhere in terms of pi. When you had a chance, look it over, pause this. Okay, so in our notes today, we are doing ELR, 11.4. So we'll be learning about the definition of volume, finding volume of prisms and cylinders. There is going to be a homework due next week, A block, Tuesday and Wednesday. Please don't forget that there is a open no quiz on Monday. The ELR is 11.1 through 11.3, and then our chapter test for this is on Thursday, Friday of March 12th, 13th. All right, so the first question I'm going to ask is, what is volume? What does it mean specifically? So volume is the amount of space inside an object. It is measured in cubic units. So we could have inches cubed, feet cubed, whatever unit cubed. All right, do you know what the volume of a 3D prism would be? A rectangular prism, any type of prism, triangular prism. What do you think that is? I bet you many of you already know it. All right, so before we get to the actual formula, even though I believe you actually know what it is, how can I find the volume of these shapes? Are the volumes of these three shapes all the same? So if we take a look, we have the left one is a rectangular prism, and then the middle one is also a rectangular prism, but it's on a slant. And then we also have a triangular prism last over here. So what is the volume of a prism? It's taking the base, finding the area of the base, and multiplying it by its height. Area of base times its height. So if I find the area of the base for the first one, it'll be 3 times 2, which is 6, times the height to give me the volume. The middle one here, the area of the base also is 3 times 2, which is 6, times the height. And the last one there, the area of that base is a triangle, so 6 times 2 is 12, divided in half is also 6 times the height. Do you think the height is the same for all three of these objects? Yes, they are. So this concept that we're just seeing here is called Cavalari's principle. So here's what they have from the textbook. It's called Cavalari's principle. If we have two space figures that have the same height and the same cross-sectional area at every level, then they have the same volume. Volume wouldn't change if it's on a slant or if it's going straight up. That's Cavalari's principle. Okay, so here's the official formula again from the book. Volume of a prism is the product of the area of the base times the height of the prism. As best as you can, see if you could sketch this prism here on the bottom. You could pause the video. It's a triangular prism, specifically a equilateral triangular prism. All the sides are 8 inches. So we need to find the volume of this. We need to find the area of that base. Well, we need base times height divided in half. We need to figure out what the height is of this equilateral triangle. We did this last unit. We sketch in an altitude. We have a 30, 60, 90 right triangle there. We know that the height is opposite of the 60-degree angle. So the height of this triangle is 4√3. So if I'm trying to find the area of the base, we're going to be doing the whole bottom, 8, times the height, divided in half. And that's going to be multiplied by the height of this whole prism, which is 10. So now let's go ahead and work it out. All right, when I multiply out, I got 16√3, timesing it by 10, the height. I multiply 16 times 10 to get 160√3, which approximately to the nearest whole number would be 277 inches cubed. Did you get that when you paused the video? Okay, here's another example. Try to sketch this one, please, and pause the video and see if you can find the volume of this triangular prism. So in this picture here, our triangle, we have our 10 as our height of the triangle, 6 as the base of the triangle. So that's easy enough for the B part, 10 times 6 divided in half. This is the height of the whole prism, 5. We multiply that by 5, reduce, and we get it to be 150 meters cubed. Did you get that when you paused the video? Okay, we're moving on to the next part of this ELR 11.4 about volume of a cylinder. Can you take a guess about what the volume of the cylinder would be? All right, so the volume of a cylinder is just like a prism, except the base of this is a circle. So the volume is going to be pi r squared, area of the circle, times the height of this cylinder. So here's our first example here. We want to find the volume of this cylinder and leave it in terms of pi. So go ahead and sketch this, pause the video, and see if you could get the volume. So when I plug in my radius and my height from the cylinder, multiply everything out, leaving it in terms of pi, I get 72 pi centimeters cubed. Okay, here's our next example. This is finding the volume of this aquarium to the nearest cubic inch. It's a combination of a rectangular prism and half of a cylinder. So if we're trying to figure out just the rectangular prism here, again, we need to find the volume of base, area of the base times the height. And here is our half cylinder on this end here. So I'd like you to sketch this in your notes, see if you can figure out the volume of this aquarium, and then watch the rest. All right, so be careful here for this rectangular prism. We have 36 by 24 as the bottom of the base. The height of this aquarium is 24 inches. So when I multiply all that out, I get 20,736 inches cubed for the volume there. Okay, so for the cylinder part, it's half of a cylinder. So I'm going to do pi r squared h, divided though in half. All right, so for this cylinder here, 24 would be the diameter. So the radius of this cylinder would be 12. So I'm doing pi times 12 squared times the height of the cylinder, 24. Divide that in half. Put that in your calculator. You get it to be about this, 5,428.672. Now I'm going to take both of these numbers and add them up. So my approximate total for this aquarium volume is 26,164.7 inches cubed. All right, for this next example, we have the dimensions of an Olympic-sized swimming pool, 164 feet by 82 feet by 6.6 feet. We want to find the volume to the nearest cubic foot. So I'm going to be multiplying 164 times 82 times 6.6 to be 88,756.8 cubic feet. Now, if 1 cubic foot is equal to 7.48 gallons, how many gallons does the pool hold? Well, I need to take this number and multiply it by the 7.48 to give me how many gallons. And that turns out to be 663,900 and change for gallons here. All right, here's our last example for this ELR. If I was there, we would have did this at the board. We're trying to choose which option is less expensive, option 1 or option 2. We are Your aunt is making a rectangular backyard, wants to do some landscaping, 70 feet by 60 feet, and she's planning to put down a 4-inch layer of topsoil. So I was talking about the volume, the height there. So she has one of two different options. The first thing that I'm going to do is change my 4 inches into feet. So I'm going to be taking my 4 inches and dividing it by 12 inches so that I am using 1/3 of a foot for that height. 1/3 of a foot. Okay, so let's look at option 1 first. Well, we find the volume of this backyard, 70 times 60 times 1/3. We get it to be 1,400 feet cubed as our volume of this backyard. Option 1 says that she's going to buy bags of topsoil at $2.50 per 3 cubic feet with free delivery. So that means we need to take our volume and divide it by 3 to get about 467 bags. We're going to round that up. They each cost $2.50, so I'm going to multiply this by $2.50. So my total for option 1 is about $1,167.50. So this is for option 1. All right, so for option 1, we got that amount, $1,167.50. Option 2 is now she would buy bulk topsoil. It would cost $22 a cubic yard plus a $20 delivery fee that we have to add on to that. So we need to understand how to convert our volume, which was the 1,400 feet cubed, into cubic yards. So let's remember that 3 feet is 1 yard. 9 feet squared would be yard squared. And then 27 feet cubed would be yards cubed. So we're not only just dividing by 3, we need to divide by 3 to the 3rd, which is 27, to change it into yards cubed. So 1,400 feet cubed divided by 27 feet cubed gives us a total of about 51.85 yards cubed. Now if I multiply that by the amount, $22, I get that to be about $1,140.74 plus the $20 delivery fee, which comes to a total of $1,160.74. So not much of a big difference, $7 compared to not. So she would choose option 2. All right, so that is it for the notes for 11.4 ELR. You could also take a look at the online notes, the Google Slides that I have there, also in the folder. What you need to do now for the rest of the period, since you have your Chromebook, is you'll find a link in Google Classroom. We did this already before last semester. You're going to be working on something called a quizzes, which is a great review of the 11.1 through 11.3 ELRs. Those are the ones that you'll see on Monday's open note quiz, so you are allowed to use your notes on Monday's quiz. This is the one where you could have a time limit of 15 minutes for each question, and it has memes that they show after each question. You'll remember once you log in and see it. Do your work in your notebook. Use your notes to help you out. Remember, you have 15 minutes for each of those questions, and that is due by Monday. When you're done with the above, then you have your options of either working on the next homework, 11.4, which is due A block of next week, and those are the numbers, or do you need more practice on the ELRs 11.1 through 11.3? Your sub person there, your substitute teacher, has those extra practice problems if you would like that.